Okay, suppose you're given the following integral, 0 to pi, 1 to 2 of f r theta, r dr d theta. And the question is, sketch the domain of integration. What would this be? What would be the integral? Over what domain is this function being integrated? That's the question. Let's think about that. Because I have r dr here, this should really be thought as r equal to 1 to r equal to 2. And the language is curve to curve and value to value, right? So curve r equal to 1 should be thought as a curve in the two-dimensional plane. What kind of curve r equal to 1 gives you? Do you know what?
Circle?
It's a circle of radius 1. And r equals to 2 gives you another circle of radius 2. Okay? And saying this from here to there means you're starting from this curve and you're ending there. Okay? However, it's not the full circle because theta is only going from 0 to pi. So what are you getting? Here's 0, and here's the angle pi, right? It's only from here until there. So you're only getting the top half. So you're not getting these. Those go away. And you're only getting from here to there. Painted radially. So you're painting this way. dr means change in the r direction. So it's painted this way. Therefore, you get this entire half donut. Okay? So that's the domain of integration. Let's try another one. What if you have integral from 0 to pi over 2 and 0 to 4 cosine theta of f r theta r dr d theta? What's the domain of integration in this case? Again, similar reasoning. R equal to 0 and r equal to 4 cosine theta should be drawn. Although it's curve to curve, r equal to 0 actually gives you a single point, right? So you're just starting from a single point and you have to go up till here, 4 cosine theta. I wonder what that is. What is 4 cosine theta? Unfortunately, cardioid would be 4 cosine theta plus 4. Okay? Yeah. I could be using that in the exam, okay? Yeah. If it was plus 4, you should be able to draw the cardioid, right? But this is only 4 cosine theta, so what's that? It's a circle of radius 2. Okay? Now, if you forgot that, here's how you think. First, it's cosine of 1 theta, meaning that you can think of it as rows with 1 petal, which is a circle that touches the origin. Right? So that's one way to think about it. If that doesn't satisfy you, here's another way to do it. Multiply r both sides, and you get r squared equal to 4r cosine theta, right? And then r squared is x squared plus y squared, right? R cosine theta is? What's r cosine theta?
X.
X. So x squared plus y squared equal to 4x is the same as this one. Okay? And then you move the 4x to the other side. And then you apply this, this trick of completing the square. You add 4 here, you add 4 there, because this becomes x minus 2 times x minus 2. If you pick two numbers that add to negative 4 and multiply it to 4, those are negative 2 and negative 2. So this is x minus 2 times x minus 2, which is x minus 2 squared. So you get x minus 2 squared plus y squared equal to 2 squared. Perfect. That's a circle with center at 0, 2, I don't know, 2, 0, and radius 2. So it's this circle that we're talking about. Right? Okay. So here's what's happening. We are starting, so we have this circle, and r equal to 0 is this point, and you're trying to paint radially. So basically what's happening is you start from here, and you end at a point on this curve. Okay, so that's what's being done if you just look at this. However, it's not the full circle because your angle is only varying from 0 to pi over 2. So which part are you getting? Only this part, right? This part has theta negative. If theta was going from negative pi over 2 to pi over 2, you're going to get the full thing, but it's only 0 to positive, so you're only going to get this part. Okay. So that's the domain of integration. Good? Now, since you mentioned cardioid, let's just do one more, the cardioid thing. So if you had 0 to pi of r equals to 3 minus 3 sine theta, and then from r equal to 0, with f r theta, r dr d theta, what's the domain of integration? Well, this r equals to 3 minus 3 sine theta, we know that's a cardioid because these two numbers match. So if it's a plus a sine theta, or a minus a sine theta, or a plus a cosine theta, or a minus a cosine theta, if it's one of those four cases, we know it's a cardioid. And to really figure out which shape it is, you probably want to plug in theta equal to 0, 90 degrees, 180 degrees, and 270 to figure out the values. Sine 0 is 0, so you're going to get just 3. So it will be 3 comma 0 at degree 0. When you plug in theta equal to 90 degrees, what's sine 90? Huh? 1, right? And you get 3 minus 3 times 1, which is 0. Okay? 3 times 1 is 3, and 3 minus 3 is 0. So you get 0. Okay? And see, because it's 180 degrees, the curve should be coming in like that. Okay? The curve should be hitting the 0 tangent to the 90 degrees. Okay? All right, and then when you plug in 180 degrees, that's sine 180 degrees, that's 0, so you get 3 going this side. Okay, so 180 degrees is this direction, and the value of r is 3, so you're going 3 steps in this direction, so you get 1, 2, 3, so this is the value. Okay? I don't know what to write. Should I write 3 or negative 3? We'll put negative 3 in terms of rectangular coordinates, but the real coordinate we're talking about here is 3 comma pi. That's the actual coordinate here, okay? 180 degrees that way, and you're going 3 steps, okay? Now, what if you have theta equals to 270? Sine 270 is negative 1. Negative 1 times negative 3 is positive 3. 3 plus 3 is 6. So you go 270 degrees direction, 6 steps. So if this is 3, you get another of that. So this is the point. I'm going to say negative 6, but the real coordinate is 6 comma 3 pi over 2. Okay, so we need a curve that's passing through here, 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 and it should be like a heart-shaped thing. So it must be like this, this. Okay? So that's the cardioid that we get. Hmm? Oh, you're going 6 steps this way in the 270 degrees. See, if I plug in 270 degrees, sine of 270 degrees is negative 1. Negative 1 times negative 3 is positive 3. 3 plus 3 is 6, so you have to go 6 steps this way. Okay? All right. So that's the graph. And because you're starting at r equal to 0, r equal to 0 is the center, this origin, and you're trying to paint it this way. Just like that, right? And it looks like you're going to get the heart if you just went from 0 degrees to 360 degrees. However, that's not what we have. What do we have? 0 to pi. So what part are we getting? Just the top half. None of these will be appearing. Only this part will be the actual. Okay, so if you drew this, the answer will be the domain that's being integrated is. That will be the domain this is integrated.